All right, everybody, welcome to your first video of your physics virtual classroom for Odysseyware Summer School. I'm going to be walking through each of the lessons that are on Odysseyware, kind of one by one, and I'm going to be making you a quick video to kind of go along with those resources and to help you understand some of the big ideas, just give you some extra support, also talk to you about the kinds of questions you can expect to see on the quiz that follows each assignment. This is not expected to kind of give you all of the information, but I'm going to do my very best to get through a lot of stuff in the shortest time I possibly can. So let's go ahead and get to it. This is your first assignment. Characteristics of waves is the first lesson. And if you look at this page, the first thing you're going to notice is that there's a lot of vocabulary on here. This is really a vocabulary lesson, a vocabulary quiz kind of thing. If you want to spend some time, going through this long list of vocabulary and practicing that, you can use the vocab or arcade feature here. Like you could select these flashcards, which will help you practice. However, I'm not a big believer in starting with vocab. I think in science in particular, other classes that might make sense, but in science in particular, that's not the best way to go. So what I'm going to do is I'm going to skip to section number 2, and we'll come back to section number 1 at the end, at least for this video. That doesn't mean you need to do that when you're answering questions. It's just what we're going to do right here. So you notice section number 2 is talking about classifying waves. Okay, so that's our big picture. That's what we're thinking of. And we're going to be trying to put waves into some categories. All right, so we're going to have the category over here of electromagnetic waves. Here, let me make myself a little bigger here. So we're going to have electromagnetic is going to be one of our categories. We're going to have mechanical over here. Okay, we're going to have transverse over here. We're going to have longitudinal. And we're also going to have 2 other categories of periodic and non-recurrent. All right, we got a bunch of categories of waves, and we're going to try to break it down sort of piece by piece into what each one means. So now that we kind of have that framework, we're going to dive back into the resources. Now, before I do that, I want you to realize these are all like 2 choices. So a wave could be mechanical or electromagnetic, transverse or longitudinal, periodic or non-recurrent, and it can be a combination of both. So it could be mechanical and longitudinal and periodic, or electromagnetic and transverse and non-recurrent. It is just kind of depends on each situation. But those are the words that we're going to be looking at as we work through this. So the first one we're going to look at, as you can see here, is electromagnetic waves, okay? Electromagnetic waves are commonly referred to, it says right there, as light waves, and are created by the acceleration of electric charge. So these are things like light, X-rays, gamma rays, UV rays, infrared, ultraviolet, I already said that, whatever. But all kinds of light, radio waves, microwaves, all kinds of stuff like that. Okay, so just some examples. The other thing we'll see about electromagnetic waves is that picture. So we've got sort of a electric wave going in one way up and down, and then we've got kind of a magnetic wave going the other way. That's why they are electromagnetic. And the most important thing that it says here is right here, is kind of buried in this sentence. It says they do not need a medium to travel. Well, what's a medium? A medium is something that carries the wave, okay? So most waves need a medium. For example, sound, that is a vibration of the air created by my hands hitting together, and that requires the air in order to be heard. If we were in a room with no air and I went like that, no sound would be produced because sound does require a medium to carry it. Ocean waves require the ocean. The water is their medium. Earthquakes have to move through the rock. That is their medium. But electromagnetic waves do not need a medium. They can travel through empty space. So we're going to say no medium. All right. The other, and therefore, this is going to help us out. We can probably already predict if this is what an electromagnetic wave is, light, and it looks kind of like that, and it requires no medium, then a mechanical wave, so I'm going to box these so that I don't get them mixed up. A mechanical wave is one that does require a medium. And I already gave you 3 examples. So sound, ocean waves, earthquakes. Those are all mechanical waves, okay? Waves in a slinky, waves in a string, those are all mechanical waves. They do require a medium. All right, let's go back and let's look at our difference between transverse and longitudinal. So here we've got a beautiful picture that's going to show us the difference. You can say in transverse waves, you're like taking a slinky and vibrating it kind of up and down like that, like going like this. And you can see that the wave is traveling one way. Like in this picture, the wave is traveling from left to right, but the vibration of your hand is up and down. So wave is traveling this way, vibration is that way, right? That is a transverse wave. The most important thing to know about that is, and it will put this in these questions, is that in a transverse wave, the vibration is perpendicular to the motion of the wave. Perpendicular being the key word there, because one is up and down, the vibration is up and down, but the motion is this way. In a longitudinal wave, that would be like taking the slinky and vibrating it like this. That also creates a wave. Or in sound, where you have the speaker vibrating back and forth, pushing out the sound that way, that is a longitudinal wave. So there we have the vibration is parallel to the motion. Okay, so perpendicular to the motion, parallel to the motion. You've got your picture in front of you. You can see the transverse wave going up and down. You can see the longitudinal wave going back and forth. You can see this up here on my screen. I'm gonna go ahead and draw a picture here of a transverse wave, and I'm gonna draw a picture here of a longitudinal wave. All right, you can see the difference there. A couple other vocab things before we come back to these that people get stuck on. In a transverse wave, we have these peaks and we have these valleys. We often call these a crest in physics, so you'll see that word a lot, and we call this a trough, okay? You'll see that in physics a lot as well. When we're talking about longitudinal waves, like let's think about sound waves are a really good example of longitudinal. We're gonna be compressing the air and stretching the air, basically. So you have these spots where there's lots of air molecules, and then you have spaces between them where there's a lot fewer air molecules. That's what is creating the vibration. We call these condensations. It's being like pushed together, it's condensed. And then in between them, we have things called rarefactions. That shows up on your vocab as well. Condensation and rarefaction. So just different words for describing longitudinal and transverse waves. All right, let's go back to our video, back to our resources real quick. And we're gonna go ahead and skip to section 3. Section 3 is talking about pulses and periodic waves. And this one's gonna be really simple. This is talking about our bottom 2 words. A periodic wave is a wave that happens repeatedly. So it's happening again and again and again, all right? So you're going to see it look like this. That's a periodic wave, all right? Whereas a non-recurrent wave just happens. That's it. You just get a single wave, all right? Just one wave all by itself. That's what a non-recurrent wave is. Now, this doesn't just want you to know what a periodic wave is. It also wants you to know two words that are related to periodic waves. So if you are counting or measuring the periodic wave, the first thing you usually look for is how many seconds is it from one wave to the next, all right? So it might take like, so for example, if I'm moving my hand like this, it might be like 1/1000, 2/1000, and then it's like 1 second per wave. Or it might be like this. I might be like 1/1000, or I might be like 1/1000, 2/1000, 3/1000. Sorry, I had to think about that. That's half a second per wave, right? Or it might be like 1/1000, 2/1000, 3/1000, 4/1000. That's 2 seconds per wave, okay? So the number of seconds per wave is known as the period of the wave, okay? We often also talk about something called the frequency. Frequency of a wave is the number of waves per second. So it's, notice, this is what you need to realize. It's exactly the opposite, okay? Frequency is number of waves per second. We often say hertz, but if you're given one, you just have to flip the fraction in order to get the other one, okay? There are a lot of questions on there that ask you to do that. It'll say something like, the period of this wave is 2 seconds. What is the frequency? You're not doing any complicated math. You're just flipping that fraction. So 2 seconds for the period becomes 1/2 hertz for the frequency. Notice I just flipped that. You can also go the other way. 1/2 hertz, if you want to know the period, becomes 2 seconds. All right, let's look back at our resource really quick, and we'll see if we have any more essential information. You also have these kind of vocab terms about waves here on this picture, talking about wavelength, amplitude, and sort of the equilibrium line being the middle part. I'm gonna let you guys look at that stuff on wavelength and amplitude if you need to, if you don't already remember that from your physics class, because this video is already starting to get a little bit on the long side, all right? The very last thing we're gonna do, so before I actually talk about this, let's do a quick review. So we've got electromagnetic waves versus mechanical waves. No medium, medium, all right? Transverse waves, you have perpendicular motion and vibration. Longitudinal, you have parallel vibration and motion. Periodic waves keep happening again and again. Non-recurrent waves just happen once. Period is number of seconds per wave. Frequency is waves per second. They're just inverse of each other if you want to solve for that. All right. So the last thing we need to do is, there are some questions on there that ask you to do some calculations. And those calculation questions require this equation. And honestly, this is where Odysseyware gets pretty rough. The resource does not tell you anything about how to use the equation, because it assumes that you can see an equation and you've had enough math background to be able to do it. And that makes logical sense when you're a physicist. But when you're actually a high school teacher and you work with students all the time, you realize that while you guys have the math skills and you can see equations, you can't necessarily put the two together right away on your own. Somebody needs to point it out to you, okay? So the last thing we're gonna talk about is this. All right, V equals F times lambda. This stands for, V is the wave speed, or I believe it says on there on a lot of the questions, the velocity. Okay, F is the frequency, and lambda is the wave length. Okay, I'm not going to explain how to use this equation in detail in this video. I'm going to save that for another one, but I did want to point it out to you as another key idea that you will need to understand. If you know how to plug stuff into an equation, you're good to go. You don't need to watch that other one, but I will be working on that video right now.